Once you have turned on the Mach 1 controller and opened the Mach 1 motion software, using the manual controls in the software, raise the vertical stage to its maximum height using medium speed. Verify the load cell calibration as per Mach 1 user manual. Perform this calibration by following the on-screen instructions. When installing anything onto the load cell, always keep an eye on the force display to see how much load is currently being imposed on the load cell. Make sure that the calibration factor is within 5% of 1.00, that is 1.05 and 0.95. Secure the testing chamber onto the horizontal stage using the 4 thumb screws. Secure the sample holder onto the testing chamber base. Gently screw the flat indenter under the load cell and lightly finger tighten to secure it. Do not apply excessive loads when installing the indenter, as this can permanently damage the load cell. Using the manual controls, bring the vertical stage downwards and carefully position the flat indenter approximately 20 mm above the sample holder. Plug the camera into the computer and open the camera feed in the Mach 1 motion software. Measure the sample's length, width, and height using the caliper and report the values in a table. Put the sample in the middle of the sample holder with its stochastic pattern side facing you. Make sure the orientation of the sample is such that the softer layer is at the bottom, whether it's the neoprene or hydrogel sample. Draw a mark on the sandpaper to remember where the stochastic pattern was exactly located to ensure exact positioning for the next sample. With the vise, secure the camera support onto the lab bench. Position the camera equipped with a 25mm lens so that its field of view covers the entire sample. Make sure that the optical axis of the lens is normal to the sample surface and points to its center. Set the luminosity by adjusting the lens diaphragm, exposure time, and gain level in the camera settings until a decent contrast between the stochastic pattern of the sample and the base layer is achieved. Set the frame interval in the Mach 1 motion software to 2 seconds per frame, that is equivalent to 0.5 frames per second, and then check the recording box. Now we can prepare the test sequence. The first function we will add is a zero load to ensure forces are zeroed at the beginning of our test. The second step is a pre-compression applied with the find contact function. This will be applied along the positive z-axis with a velocity of 0.1 mm per second with a contact criteria of 1 newtons. In this case, there will be no stage repositioning. We will then add a wait function for a duration of 10 seconds. And finally, the shear sequence is achieved with the move relative function. The amplitude of the move relative function should be set such that it is 10% of the measured sample height, in this case 1.2 mm. The velocity is set as 0.1% of the sample height per second, that is 0.012 mm per second. In this example, a faster shear velocity is applied for the purpose of time. Make sure to select the correct stage axis, that is along the x direction. You must also save the move relative function with the following format. Execute the pre-compression and shear sequence shown on the screen. During the test sequence, it is very important that the lighting must remain constant throughout the video acquisition. Therefore, avoid any unnecessary movements in your surrounding that would cast shadows on the sample. Once the test sequence is completed, using the manual controls, raise the flat indenter and bring the horizontal stage to its middle position.